Hello, Algebra 1 class. We're going to take a look at our 9.7 samples, preparing for our quiz 9.7, where we're solving systems that include a quadratic equation and a linear equation. So remember that even though we're not graphing these, we are looking for the 1, 2, or no points of intersection for this parabola from the quadratic equation. If we were to graph this, we would get a parabola. And the linear equation, if we were to graph this, we'd get a line. So we're looking for where does this parabola and this line intersect at no points, 1 point, or 2 points. Well, for this particular problem, we're going to find 2 points where this line intersects the parabola. Let's see how we do it. Well, we're going to use substitution to solve this system because they are both these equations are solved for y, which means that this is a really good system to solve using substitution. So I'm going to choose to substitute negative 2x squared plus x plus 1 in for this y. We're told it is y. That means I can put this trinomial in place of y and say that's equal to 5x plus 1, and then I can solve that equation for x. So that's what I'm doing. So I'm going to rewrite this top equation, and instead of y, I'm writing negative 2x squared plus x plus 1 equals 5x plus 1. And I'm going to then subtract 5x and 1 on both sides. And I'm going to get equal to 0 because I'm going to notice I have a quadratic equation, and I'm going to think that factoring might be a really efficient way to solve this quadratic equation. In fact, that will turn out to be the case. When I'm equal to 0, I'm noticing that I do have a greatest common factor of negative 2x that I can factor out of both of these terms. So factoring out negative 2x, what remains is x plus 2 because negative 2x times x is negative 2x squared. Negative 2x times 2 is negative 4x. So I have two factors multiplied together, and when I have that situation equal to 0, I can use the zero product property to solve for x. So I'm going to set each of these factors, negative 2x equal to 0 and x plus 2 equal to 0, and solve to find out the two x coordinates of the points that intersect the parabola. All right, so negative 2x equal to 0, divide both sides by negative 2, and 0 on the top, okay, 0 on the bottom, no way. So I'll get x is 0. And then over here, x plus 2 is equal to 0, subtract 2 on both sides, and x is negative 2. Okay, so great, I have my x coordinates for the 2 points of intersection for my parabola and my line, but I need ordered pairs to be able to identify where those points are. So I'm going to use my x is 0 and x is negative 2. I'm going to plug those values into the easiest looking equation up here from my original system. I'm going to pick off that the easiest equation to work with, and it looks like it'll be that bottom one, that linear equation. I'm going to put in the values I got for x, and then I'm going to solve for y. So I'm going to bring y equals 5x plus 1 down here. When x is 0, y is going to turn out to be 1 because 5 times 0 plus 1 is 1. When x is negative 2, when I plug that into my equation y equals 5x plus 1, I'll have 5 times negative 2 for x plus 1, and then it'll give me negative 9. So my answer to the question, what is the solution of the system, are the two ordered pairs 0, 1, and negative 2, negative 9. These are the 2 points where that line would intersect the parabola. Okay, our last sample here will be similar to our first sample. We're going to solve the system of equations, and again we have one quadratic equation that would graph into a parabola and one linear equation that would graph into a line. We're looking for the 0, the 1, or the 2 points where that line intersect the parabola. Well, again on sample 2 we're going to find there's 2 places where that line intersects the parabola, and so let's see how we work those 2 points out. Again, we have both equations equal to y, so substitution will be a great method choice here to solve this quadratic system. So I'm going to go ahead and take my 3x squared plus 2x, which is equal to y. I'm going to put it in place of this y. So I'm going to rewrite the second equation as 3x squared plus 2x, that's in place of y, equals negative 7x minus 6. Now I'm going to notice that I have a quadratic equation to solve. I'm thinking factoring might be a good method choice. So I'm going to get equal to 0 by adding 7x to both sides and adding 6 to both sides, giving me the quadratic equation 3x squared plus 9x plus 6 equals 0. Well, actually, before we get there, we would end up with 3x squared plus 9x equals negative 6, then adding 6 to both sides. We get our 3x squared plus 9x plus 6 equals 0. I'm noticing that I can factor out a 3 from all 3 of these terms. 3, 9, and 6 are all divisible by 3, so that's my next step, factoring out 3. What remains behind is x squared plus 3x plus 2 because 3 times x squared is 3x squared. 3 times 3x is 9x. 3 times 2 is 6. Then I'm going to divide both sides by 3 to kind of get rid of that 3. I don't need it. And I'm left with x squared plus 3x plus 3 equals 0. And this is a much easier equation to factor than if I were to try to factor this. I could have, but this way is easier. All right, so this factors into x plus 2 times x plus 1 using our x method. And we're going to notice that it definitely is correct because x times x is x squared. Our outside 1x plus our inside 2x. 1x and 2x makes 3x. And 2 times 1 is 2. So again, I'm noticing that I can use the zero product property because I can set both of these factors equal to 0 and solve for x. When I do that, I find that x is negative 2 or x is negative 1. Now I need to find the y-coordinates that match with these x-coordinates to find those 2 points of intersection. So I'm going to go back to my original system. I'm going to pick off what looks like the easiest equation up here to solve for y knowing x. And it looks like it's this bottom equation again, this linear equation. I'm going to plug in both values I got for x to work out my y. All right, so y equals negative 7x minus 6. Plugging in negative 2 gives me y equals 14 minus 6, so y is 8. When x is negative 2 then, y is 8. So one of my ordered pair solutions is negative 2, 8. When x is negative 1, plugging that in for x, I'd have negative 7 times negative 1 minus 6, giving me 7 minus 6, and 7 minus 6 is 1. So my other ordered pair solution would be negative 1, 1. These are the two ordered pairs where the line and the parabola would intersect each other. It is the one, both of these are the x and y coordinates that would solve both equations correctly. All right, that completes our samples here. So for our lesson 9.7 samples, please make sure these are recorded on your paperwork, and when you're ready, move on to taking the quiz for 9.7. We'll see you next time.